All right. So, a couple things off the top. I went through, I think I've got every ICR score, as well as any excused absences kind of taken into account in the grade book. I then dropped everyone's lowest 3 scores and put what your kind of final iClicker grade will be for the class, okay? So that's there. After today, that 5th Connect and 4th Excel, I'll move to kind of, so they count towards your grade and should be kind of grading those 4th Excels starting tomorrow. I've got a couple sections, so I don't know if I'll start with yours or the other section first, but I'll start kind of throwing those up there. And then we kind of have those final 2 that if you missed one before, or you want to try and improve your grade, you can kind of do one of those last 2. Remember, I drop the lowest of each type. So I'll drop your lowest Connect, your lowest Excel, and your lowest Learn Smart assignment, okay? I'll also, since we're done with Learn Smarts, I'll get up something very similar where I have kind of your Learn Smart score with your lowest dropped, right? So I should be able to do that tomorrow. It's a lot easier than the iClicker, so I should get through that. I might even get that up there this afternoon. And then once you have those, you can kind of look at what, if you look at your grade book, you can kind of see what your score was. Let me show you here. Right, for the Learn Smarts, for the Connects. Now, obviously, once I get the scores up with the lowest drop, that's the one that you can use to, if you go here, I put, where is it? I could have sworn here it is. Figure out your grade, right? So if you click on this and download it, it's trying to open. There we go. So I have like a hypothetical person in here, but basically you can play around with, enter in what your kind of Excel category grade was, your iClicker grade with the lowest drop, your Connect grade, etc. Enter in your first 2 exam scores, and then you can play around with, okay, this person, if I get, 45 on the final, well, I'm still ending up with a C. If I get a 40, still, I mean, this, if I'm thinking about, okay, I could do really bad and still end up with a C in the class. Or, if I get like a 90, okay, I can bump myself up to a B, right? Or, whatever your situation is, you can kind of play around with this and figure out what final exam score I need to get different grades in class, right? That way, I think every professor should give you one of these leading into exam week. That way, you know where to kind of allocate your time resource, right? Wherever it's going to be the most beneficial in terms of improving or, kind of minimizing the loss of a grade there, okay? Any questions on any of that? Okay, so that's up there on Canvas. We did this last class. I also put up kind of some additional slides we'll kind of look at today. So we'll just be going through more examples of linear regression. I'll show you a paper that I think is kind of interesting as well, and we can maybe see how this is put into practice a little bit more. So I think this is the one I want, yeah. So let's say. So I think we left off kind of, talking about causation correlation. We looked at that GPA data. So I've got some additional things that we can kind of think about as well. So this is somewhat of a broader kind of picture. So we'll start out, and it might seem like a really stupid kind of thing to look at, but I think there's a broader kind of decision-making that we can kind of see how universities could use some of this regression output to make decisions at the end of the examples. So let's say, we wanted to do something like this, right? So if I had just done a very simple linear regression where I'm trying to predict, right? I guess usually in the spring, this is a little bit more relevant. But if I'm thinking about kind of the NCAA tournament, it's huge. This huge thing that, goes on. People bet on it that don't even really necessarily are that into basketball. And it gets a lot of these universities' names out that you might not otherwise hear, right? And so a lot of these universities, you can almost think about it as success potentially is almost like free marketing, right? It's not free, right? You have to probably, have some expenses related to your athletic department, but universities might be interested in, okay, how can I make sure, and I call it round one, that I just get into that tournament, right? And is that a function of how much money I'm spending on my basketball program, right? Or basketball expenses, okay? So, universities might really be interested in this. If I increase my expenses towards my basketball team, right, pump more money into that program, what's the predicted increase in whether or not I make that tournament? So I don't think we've looked at an example yet where our dependent variable is just a 1 or a 0, right? We looked at that last class, like the athlete, right? The independent variable, or the right-hand side variable being 1 or 0, and how we interpret that. But what if our y variable is just a 1 or 0? Well, here it's still the same interpretation. So a 1 unit increase in my x variable. So basically a $1 increase in my basketball expenses would now lead to whatever that coefficient estimate is for B1, will lead to that change in the predicted y value. Well, now our y value, it's either a 0 or a 1. So now this can be interpreted as what's the unit of my y variable? It would be, how do I write this? So a beta 1 change, right? Increase or decrease depending on the side in the predicted probability, right? So now my units, if I have a 1, 0 variable as my dependent variable, the predicted change is now going to be the predicted change in the probability that I go from a 0 to a 1, right? Or that I make the tournament versus not. So before we would say something like, $1 increase in my basketball expenses would lead to some type of unit change in my y variable. Well, now my units for a 1, 0 variable, my y variable, are just going to be a change in the probability. Okay? So the interpretation is just a little bit different there when we have this 1, 0 variable as my dependent variable. But this is interesting, right? If I spend an additional dollar in my basketball program, how much does that change the probability that I then make the tournament, right? Now, obviously, a $1 change is going to be relatively small. So once I obtain that coefficient estimate, I probably want to know, well, what's the impact of spending, 10,000 additional dollars? Well, just multiply that by, the effect of $1, right? And that gives me the effect of $1,000 change. Okay. So that's the general idea of what we're going to do. Now, the problem is, if I don't use any other controls, what types of schools are likely to have higher basketball expenses? Schools that are just larger, right? They have higher enrollments. And that's on average. There might be some with lower enrollments, but maybe that's something we want to control for. So I might throw in that additional control, which is controlling for the total number of undergraduates. Right? So we talked last class, if I had left that out, I would have had this bias component. Right? When I'm looking at that estimate for beta 1, or I was calling it B1, kind of the same thing. When we look at that in academic papers today, we'll kind of see they usually use betas. But I would have been picking up this additional bias term if I didn't include this X2 variable that I think matters, which is total number of undergraduates. Okay. And I said, I'm not going to make you sign this, and I'm using this for another class where I maybe expect them to. So we don't have to kind of worry too much about, can I put a sign on this bias? But we do need to know that it exists if I don't include this total undergraduates in my regression. Okay. So we'll go down. I can skip that. We can kind of see, if I run that naive regression, and this is something that's different than Excel output. So it still shows us the same things, right? It's giving us our R squared up here, right? So we're explaining 17% of the variation and whether or not a university team makes that NCAA tournament just from looking at their basketball expenses. And that makes sense, right? The amount of money they're spending on the team likely is one of the pretty contributing factor. It's explaining about 17% just on its own. That's with no additional controls. We then say, okay, well, this estimate's pretty small, right? E to the -8 means move that decimal 7 places to the left. But remember, we said that's the effect of a $1 increase. I mean, $1 is not that much of an increase. We probably want to think about, well, what's the effect of a $10,000 increase? Well, if I multiply this by 10,000, I'm going to start to get things that look a little bit more realistic. And we'll look at that in the next slide. But for now, here's our coefficient, right? Well, we then included total number of undergraduates. That estimate fell a little bit, got a little bit smaller. And that makes sense because before it was giving me the true relationship plus this bias term. But once I included total number of undergraduates there, it eliminated that bias. Okay. So for both of these variables, right, looks like they have a positive effect. How would we interpret this total number of undergraduates coefficient? So how would I start out that interpretation? What's the units of that X variable? If I had one more student enrolled, right? The increase in the probability that that team would make the NCAA tournament would go up by 0.00004. So pretty small, but one student, once again, is a small unit change. We might want to think about what if the university had 100 additional students, right? Or 500 additional students, right? And then we would start to get some probability changes that are a little bit larger. Okay? So here was that estimate we obtained on that expenses variable. Right? It looks very small, but that's the effect of $1, right? So, most teams, I think the average expenditures was 1.3 million, right? So if you're talking about a $1 change, I mean, we could see changes of, a couple $100,000 here, okay? And there's some schools, I think, I feel like this might have been, I can't remember the maximum school. It was like, I think it was either Louisville, Kentucky, or something like that. We had $22.9 million, right, was the expenditures of the basketball program. So we could see some relatively large changes. In fact, the standard deviation is 1.8 million. So thinking even about a $1 million increase in expenses, isn't that wild, right? So if we think about schools that were outside the kind of top 100, right, in terms of size, or and if we ordered the kind of expenses from smallest or largest to smallest, those outside the top 100, if they had a 10% increase in their expenditures, that would be just about $1 million. Okay. So if I know the effect of a $1 increase, I can find the effect of a 10% increase, which was 935 million, by simply taking that coefficient estimate and multiplying it by whatever that kind of increase I wanted to think about was. Here, that was a $935,000 increase. So if a school, or sorry, not outside, in the top 100, increase their budget by 10%, which is almost $1 million, that would increase the probability they make the tournament by about 0.069. So that's the probability. It would be a 6.9% increase. Okay. Now, I don't know if I would kind of, when you think about studying for the exam, I wouldn't push you necessarily this far. Today's class is more so, we're just getting more examples. We're kind of seeing the power, how far we can push it. But these general ideas of, I can always scale up the effect of one unit by simply multiplying it by however many units I want to think about, right? Here, that just happened to be 935,000. Okay. Well, what if we think about maybe some other schools like IU? Well, they have a $10.2 million budget, so a 10% increase for them would be a little bit higher. So if they had a 10% increase in their budget, the effect of $1 is 0.0000007. The effect of a $1.2 million increase would be that times 1.2 million. So if they increase their budget by 10%, they would have about an 8.8% increase in the probability, or in the likelihood that they make the NCAA tournament, which is not a minuscule effect, right? I mean, what's the greatest I can increase my probability? 100%, right? Going from 0 to 1, but here it's an 8% increase, 9% increase is pretty good. What about schools like just outside the top 200, like Ball State? Well, a 10% increase for them would be $150,000, right? Their budget's a little bit lower. So if they increase their budget by 10%, they would increase their probability of making the tournament by just over a percentage. So we could think about, we could do this for any school, right? Once we obtain that coefficient estimate. So every university could then look at their budget and say, look, if we increased our budget by 10%, this is the increase in the likelihood that we make this huge tournament. Okay? And it's great. Right? We're in Indiana, everybody loves basketball, right? So maybe the schools want to make sure that they have a good basketball program. There's something a little more interesting here, right? So let's say they look at this and say, okay, we can increase our chances that we make the tournament, but why is that beneficial to the university, right? Well, you do get some money from I think technically, like, it goes to the conference divvies it up and they give it back to the school, but you would still have some revenues coming in from this additional expenditure possibly, right? But there's also some additional effects that we could think about, right? But before we do that, we can get an even more accurate estimate. I had some data laying around, which was, well, did the team make the tournament in the previous year? That kind of controls for like the quality of the team going into the season, in the season. Same kind of thing, previous number of wins. Well, they have high expenses. Maybe it's because they also know they can generate high revenues, so I'll control for revenues as well. We can do this interesting thing, which is if I had a variable like year, if I just include, like, let's think about the most simple one, right? If I did like round one and I just included the variable which measured what year it was in, what that essentially does is it forces the relationship between my y variable and this x variable to be linear, right? But maybe it's that different years saw like wildly different jumps, and there's really no functional form to this relationship. So what we can do is simply break year up into a bunch of different indicators. So I might have, year 2020. This is just a 1 if the observation was in 2020, 0 if not. I would then have another indicator for 2019, 1 if the observation was, so I could include all these indicators, 1 for every single year, leave 1 out so that I have like a base comparison, right? And that doesn't force me to have this linear relationship between year and my y variable. Okay? So that's kind of an interesting thing to do. It doesn't like really restrict that regression as much. So I include those as well. We can then throw all those into our regression, and now notice our coefficient has fallen quite a bit. Right? I think it was like 7 point something, moving the decimal point 8 places. Now it's only 2.3. Okay. However, if we look at these p-values, they're still relatively small, right? I mean, this one looks like total number of undergraduates. Once I start controlling for these other factors, that's not as predictive, right? Just having more students doesn't necessarily impact my athletic success probability. But when it comes to like the variable we're thinking most interested in, basketball team expenses, that still has a p-value of 0.001. So remember, for every coefficient, we essentially have the hypothesis test, which is we assume that that relationship or that slope coefficient is equal to 0, right? Or we're assuming that there's no relationship. So when I'm finding these really low p-values, I know that if the p-value is less than alpha, I can reject. So if my p-value is 0.001, that's going to be less than any of my benchmark alphas. So I can reject the null, or I can reject that there's no relationship. So not only do we find this effect, we can say that it's significant, right, at every single alpha level, or every single significance level, or every confidence, right? 90, 95, 99% confidence levels. So, we could go through, do the same thing for the national championship. I'm not going to waste time on this because I want to kind of go ahead to something that's a bigger picture. But you could do the exact same thing to see whether or not, you win the entire tournament, where it's just a 1 if you win, 0 if not, right, in this historical data. What's a little more interesting is, okay, we have this athletic success. We think maybe it generates some additional revenues, but could also impact the university, right? So there's kind of this like, I forget what they call it, but it's this line of research that's looking at how different attributes of a university might increase demand from students, right? This is kind of a weird thing to think about, like, but this is like the economics of it. So does basketball success potentially help universities in other areas, right? So if it gets my name out there, like I always use the example, if you're from, you're from Indiana, maybe you've heard of, or like that Valparaiso exists. But if you're out in California, you might have no clue where Valparaiso University is, right? Or that it even exists. So if these teams at universities you've never heard of start popping up, while you're in high school, and they just hear the name, and then the announcers are talking about how great their academics are, like the other couple of years ago, Loyola Chicago, right? You look in the university, and you might end up saying, oh, they actually have some good programs, So it makes people maybe just aware of the university, makes the chances that they look into that university a little bit higher. It's basically free marketing, not free, but it's once they're in the tournament, it's free marketing, right? Their name is on all these brackets. So maybe they get more applications, right? And if I get more applications, even if I don't take more students, what can I do? So if I had 100 applications and I want to make sure I have 100 students, I got to accept all of them. If I have 1,000 applications and I only wanted to take 100 students, what am I going to do? Yeah, I'm going to pick the best, right? So if I get more applications, excuse me, maybe not only do, I could pick that up if I could get data on applications, but I might also see the quality of my incoming freshman class be a little bit higher, right? So we're going to look at first, how does success in that tournament impact kind of the following year's applications? Now, it has to be the following year, because think about the process, right? Their name's out there, and then people are applying, and the following year is when you'll actually see it show up in the data. So I actually kind of went out and grabbed some data on applications, and then I had this X variable or right-hand side variable, which was, did they make the tournament in the previous year? If they did, it's a 1. If not, it's a 0. Okay. So what we're thinking about here now is, I'm trying to predict the number of applications a school receives by whether or not they made the tournament in the previous year. So the interpretation of B1 here, a 1 unit change in my X variable, well, now my X variable is the one that's 1, 0. So going from the 0 group to the 1 group, or going from not making the tournament to making the tournament, would change the number of predicted applications by whatever coefficient estimate I get for that slope B1 is. Okay. Any questions on anything up to this point? It's supposed to be interesting, so if you have questions, feel free to ask. Okay. So we look at that estimate, and sure enough, if I make the tournament, it would predict that I get about 7,000 additional applications. This seems wild. It seems like it can't be right. Well, it's a very naive regression. I have no additional controls, right? What is probably true is that schools that make the tournament are more likely to be larger schools to begin with, and so we would just expect that they have a higher number of applications. So a really good control would be control for how many applications they got the prior year, right? That way it kind of gives us like a baseline, and then the thought experiment would be 2 schools that have the same number of applications the previous year, but now one of them makes a tournament. The additional increase in applications would be whatever the coefficient estimate is. So I did that, right? I controlled for the previous number of applications, and now it looks like making the tournament only increases number of applications by about 100. Okay? That seems a little bit more reasonable in terms of just thinking about the size of these effects. And yeah, it's not quite significant, right? A p-value of 0.135, we couldn't technically reject the null. So if we can't reject the null, we can't reject that there's no relationship. So we can't really say that that relationship is anything other than that assumed true value of 0. However, this is where, anytime you read a study or sometimes I look at these media articles, and they'll link an actual study like this that you can look it up, you can see their results. Sometimes they will suggest that there's a sizable effect, even though the p-value is 0.4. It's well, okay, but there's very you found that there was something other than 0, but you can't say it with a reasonable level of confidence that it actually is anything other than assumed true value of 0. Or you'll have something like this where they say, well, they found that there's absolutely 0 impact of making that tournament on their following applications, where you're okay, yeah, you can't say it with 90% confidence, but I could say it with what? 86, 87% confidence here. That's not that different, right? So you always want to kind of look at and see when they're putting out or summarizing some of these research findings, they can be a little bit misleading sometimes, right? And really what you want to focus on is kind of that p-value. That tells you kind of what level of confidence you could really say this is different from 0. And I would argue 86% confidence is still pretty decent. So I say next level regression, we add in kind of state fixed effects. So remember when I told you could include all these indicators for the different years? You can also do the same thing where I control for what state this school's in, right? Well, now this gives me even more power, right? Because we know different states have different populations, different demographics, income levels, right? And so now the thought experiment is 2 schools with the same number of previous applications and that are in the same state, but one of them makes the tournament. Now the predicted increase in the number of applications is 167, and it's significant at what? the 90 and 95% confidence levels. So this really shows the importance too of like, if you've got data, if you include these additional controls, you really should, right? Because this bias, like there's bias with every single variable that you omit, as long as the omitted variable is somewhat related to kind of the X variable that you've included. So here we can control for the state. That's a lot more powerful, right? Now you couldn't, well, you could do this in Excel, but it'd be a big pain, right? There's a lot of programs out there like Stata, SAS, R, where you can use these little commands and it takes that state ID and basically created all these indicators for me behind the scenes. So, you know, this regression analysis is really, really beneficial, but you're going to be somewhat constrained in Excel. So that's why like there's this huge push. Some of the classes, you know, upper level courses, hopefully, I don't know, has anyone had a class where they like have you even mentioned R, Python yet? So like I know that our advanced stats, so that I think it's ECON 321, they start to really use R a lot. And if you can put that on a resume, you just moved way up the list when the recruiters are looking at you. So actually just had an old student reach out last week and I sent them, I don't know if I've given you the spiel yet, but if you go on Data Camp, there's like free courses where you can, I mean, you can only go so far and be free, but they've got R, they've got Python, all these different like programming languages. I think they've even got one for Excel, and it can just kind of help bolster your knowledge of these things. And if you end up liking it or, you know, find it relatively easy, I think you can get certifications and stuff on it, and putting that in your LinkedIn or on your resume will be really beneficial. Yeah. Data Camp. I'll put yeah, let me write this down and help bring these. I'll put an announcement up with it. Yeah.
I was also going to say Ball State offers the LinkedIn Learning for free, so you can also do certifications through there if you don't want to have to pay for Data Camp. I don't know which is better.
So I would say those are good. The ones on LinkedIn. The only issue I have with the ones on LinkedIn, I feel like you almost need. It's not as good at teaching you it. So like one good thing might be do the free portion of Data Camp, and then if you go to the LinkedIn one, you might be able to like actually work through and get that certification. So the only thing I like a little bit better about Data Camp is, especially the free intros, it really like starts out like you don't know anything, which I mean, there's no reason you should know anything about R. So like it's a good like kind of introduction to it, kind of getting those basics down. But yeah. Any other questions? All right, so that was my side. So, you know, if I'm a university, not only do I look at this and say, well, athletic success could be good if we make the tournament, right? Maybe that draws in additional donors or something like that. I don't have data on the donations. But right, it's not just that athletic department that might be benefiting, it's the entire university, right? So the university gets more applications, maybe they can be a little pickier. So there's data out there that every university reports, which is what their incoming freshman classes, and this is a little bit older data because now a lot of schools have made it optional. But back in the day, like every major university, like you had to submit your ACT or SAT. And so each school kind of has to report what their 25th and 75th percentile of their ACT scores for their incoming freshman classes. So I just use the 75th to really see like, are they really able to like increase that right side of the distribution, right? Really able to like get higher quality students, right? And draw up what their 75th percentile would be. So I use the ACT math, right? It's a kind of how they had it reported. And you can see here, if I control for the previous number of applications, making the tournament increases that 75th percentile in the ACT by about 1.5. It doesn't sound like much, but imagine like the incoming freshman class, you're able to like pull up that 75th percentile by an entire 1.5 points in the ACT. That's a pretty sizable increase, right? So universities, yeah, they are getting these additional applications, and it looks like as a result, they can be a little bit more choosy with their incoming freshman class. Okay, so I guess maybe if you were on the bubble, you would tell a high school student apply to the schools that didn't, right? Because there'll be a little bit less competition. But we see the same kind of similar sort of thing with English, right? A 1.8 increase in that 75th percentile. So success in this tournament can be purchased, right? That expenses variable going all the way back to the beginning increasing your expenses had a significant effect on whether or not you made the tournament. And then whether or not you made the tournament has dividends in the number of applications you're getting and the quality of student that you can then kind of subsequently accept. Okay. I think, and this 1.8, 1.7, the standard deviation is 3.5. So a lot of times we think about, okay, what was the magnitude of these effects, right? 1.5, 1.8. Well, if the standard deviation is 3.5, it's a little bit less than or right around half a standard deviation, which is a decent move, right? But yeah, so I don't know. I always kind of like this when I got this data. I was thinking about, what's the broader, like, you can use all of these different regressions to really understand like a very broad, generalized question. There's a lot better studies out there that do this. I just kind of had some data that I figured I'd do it as well. But they find it for football success, I believe, has something to do with like the college football playoff. They've done something similar to this and see similar effects. Right? Any questions on this before we keep moving? So hopefully we're kind of getting an idea of like how powerful this can be, this linear regression. I didn't know if we would get there today, but I put them up there. If you didn't take a look at this, it's okay. I actually am going to put up one more file that I'll kind of talk a little bit about Friday that I think is an interesting regression example. And then we'll kind of start doing some exam review on Friday. Okay. Also, I had someone ask, and I wanted to do it yesterday, and I kind of wanted to use a room, and then it was not available, and I didn't get around to it. So tomorrow for sure, or I might even do it. I might come in tonight and do it. I'll film myself working through one of the practice exams, so you can see not just the answers, but how I arrived at them. And then whichever one I film, I'll do the other one in class. Okay. All right. So this is a pretty popular line of research recently, which is, a lot of different states are legalizing marijuana. This one I think was just looking at medical marijuana because it's a little bit older. But there's some interesting questions that you can have. So the one that they're going to kind of focus on is kind of like this idea of, are alcohol and marijuana like substitute or complementary goods, which is kind of a funny way to think about it, but maybe it is, maybe they really are substitutes, or maybe they're complements, right? And then after legalization, maybe you see this increase in the use of both, or maybe you see, because marijuana is now legal, right? You see a decrease in the use of alcohol, right? They're substitutes. So they're going to kind of explore that, but they're specifically going to look at something that has real, big, real world implication, which is, how is it also related, this medical marijuana, to traffic fatalities? Okay, because if they are substitutes, if people are using less alcohol and you believe that the driving while impaired on alcohol is different than marijuana, then maybe you're actually saving lives. Right? Maybe you see fewer drunk driving fatalities. So you could read through this whole thing, but the most interesting part of any paper like this in economics or finance is the tables. So usually if you look up on Google Scholar, some thing that you're interested in, the tables are usually at the end. So I'll go just to the tables that I know are interesting. So let me see. Scroll down here. Here it is. Okay. So basically what they're going to do in this paper, and I'm simplifying it a little bit, but for the sake of where we're at in class, they're going to look at traffic fatalities as their Y variable, and they're going to try to predict that using this indicator for whether or not medical marijuana was legal. So this should tell us that going from being a state where medical marijuana wasn't legal to then it is legal, what's the change in the number of traffic fatalities? Okay. And then kind of break this down in different categories, like what about traffic fatalities where there's a blood alcohol content over 0, blood alcohol content over the legal limit. And so they have a bunch of additional controls as well. Okay. So if I remember correctly, let's see if they specify, they have unemployment, income, the average number of miles driven by people in that state, whether or not the person had was on a permit or had a license, seatbelt laws, controlling for the blood alcohol content level, controlling for taxes on alcohol, controlling for the speed limit right, or the maximum speed limit in that state. So they try to control for all these other factors. And then now the interpretation is holding all these other things constant. What's the impact if they have medical marijuana legalized? And this is just medical, right? This is going back to not even recreational yet. So what they find is the coefficient, and they just simplify, right? They don't show you the coefficient for everything. They just show you the coefficient on what they're interested in, this medical marijuana being legalized. So you can see here, if a state holding all those other factors constant, if that state has medical marijuana legalized versus not, traffic fatalities go down by about 0.24. And I believe this is per 100,000 drivers. So you could scale this up for different states. I mean, states that have, think about California, how many, I mean, they'd be saving a ton of lives, right? Take their population, divide it by 100,000, and then multiply that by the coefficient. That's how many lives you save, right? So this is just how many lives per 100,000 people. Most states have more than, well over 100,000 people, right? So you can scale this up for different states. They then started adding in additional controls. So like they did those year and state fixed effects. I showed you those examples earlier. Fixed effects just means that you're including indicators for every single state and for every single year, right? So that's a lot more powerful. And it changes the estimate a little bit, but it's still, still significant. So when you look at academic papers, instead of telling you reporting to you the p-value sometimes, although here they were nice and they did, actually, are these standard errors or p-values? These are actually your standard errors. So they don't even give you the p-values. But what they do is they start to use stars to tell you what level of significance this coefficient estimate you could reject the null at. So 3 stars means you can reject the null with 99% confidence. 2 stars, 95, 1 star, 90. So here, these are very significant estimates. And then even after they start trying to add in additional controls, they start adding in state-specific time trends in fatality. Like this is some crazy stuff. And they still find that it decreases traffic fatalities, which is, a pretty interesting result, right? As a politician or a policymaker, here this gives me some pretty good ammo to argue for the legalization, right? They then kind of break this down and say, okay, did it have an impact on fatalities where no alcohol was involved? And what they found was, okay, it's negative, but this is not even close to being statistically significant. We can't reject the null. So we can't say that medical marijuana being legalized has any impact on fatalities where alcohol wasn't involved. However, what they found was that for fatalities where you pick up any blood alcohol content above 0, it reduced those by a little bit more than if we just included all fatalities together. And it decreased these extreme blood alcohol content measures and fatalities by the most, right? Negative 0.15. So here we've got evidence, not only is it reducing traffic fatalities, but primarily those where high levels of alcohol were involved. So maybe this is evidence that alcohol and medical marijuana are a little bit of substitutes, right? Even if people, use them at the same time complementary, at least they're not using as much alcohol as they were before. Or it's at least they're not using as much and then kind of result in them driving and to put it bluntly, killing someone, right? So like this is you can think about these laws would really be saving lives. They then break it down and make it not just whether or not it was legalized, but how many years has it been legalized? And they kind of did what we call this a falsification test. Like if I go years before medical marijuana is legalized, I should see no effect, right? Because it wasn't legalized. So it's like almost like if I picked up an effect there, I'd be concerned. So it's like this falsification where there should be no effect. So hopefully I don't pick up on one. So all they did was include indicators now, not just for whether or not it was legalized, but an indicator for if it was legalized between 0 and 1 years, an indicator for was it between 1 and 2, and then looked at all the coefficients there. So as expected, these years before the change, and even the year that the law takes place, nothing is significant, right? There's no stars, which means none of the effects are anything other than 0. We can't say that there is any relationship between having, 2 to 3 years before it was legalized. There's no impact on fatalities there. And what you'll notice is even at like 0 to 1 or 1 to 2, we start to pick up some significance, but really the results are being driven by once that medical marijuana has been legalized for 2 to 3 or 3+ years, that's where the reduction is really happening. Once people have access to it and are actually using, right, the law or taking advantage of the law, then we really start to see these traffic fatalities decrease. Okay. And notice here, the effects are significantly larger for these extreme blood alcohol content measures as opposed to just any blood alcohol content. And I think what's one of the more interesting, this is sometimes people are think more than I would have on this, but they also break this down by time of the day. So the data they actually had when the accident occurred. So they said, okay, what's the impact of having medical marijuana legalized on fatalities during the week? And they find a negative effect, but it's a little bit smaller and it's not significant. And what they really find is fatalities on the weekend and fatalities at night are where you see the highest and the significant effects, right? So this kind of makes sense, right? I think there's probably far more traffic fatalities from alcohol use on the weekend at night as opposed to during the day, during the week, like a weekday during the day. So, and that's using all of their like extreme controls here. So they're trying to throw the kitchen sink at this to control for any other outside factor to make sure they've eliminated any of that bias that might exist. Okay. So pretty strong argument. I think they did break this down by age as well. Not surprisingly, the estimates for people over 50, medical marijuana being legalized didn't really change traffic fatalities in a significant way, right? There's no stars here. These weren't significantly different from zero. And the real effects were being driven by young people, right? 20 to 29, that's where we saw the greatest reduction in traffic fatalities after medical marijuana was legalized. So, this is a consistent story, like nothing, this kind of would fall in line with what you might think. And then, of course, they find that it kind of decreases traffic fatalities that involve males more than females, right? That potentially there's kind of a greater reduction in male traffic fatalities than females after medical marijuana is legalized. And I think that was the last variant. They started breaking it down by some other things, but these variables are a little bit goofy. The traffic fatality one is really where we want to kind of think about, the real strong argument here, right? That you're saving lives. Just to mention, I think what they did do down here, these were some measures of alcohol use, and you can kind of see most of these estimates are negative. Not all of them are significant. They're primarily kind of being driven at younger ages. They looked at state level sales. They saw some reduction in beer sales. Looks like wine or kind of liquor, there was no real impact on. So they tried to paint this real complete story where they had these measures of, well, it looks like beer sales are going down after medical marijuana is legalized. It looks like use, right, binge drinking and the number of drinks, I think this was a number of drinks a month, they're all going down. So it looks like maybe these are, in fact, not complementary goods, but they're to some degree substitutes, right? Once you have marijuana as a potential legal option, you reduce the amount of alcohol consumption and you reduce the negative side effects of increased alcohol consumption through things like traffic fatalities. There's like similar studies out there. You can I don't know if you guys have used for other classes. It's called on Google. You can use Google Scholar, and it basically shows you all these academic papers. This is like a bunch of really interesting research. Most of it's from Colorado since they're like an early adopter, but they've done things like this for crime rates. They've done things on, all these negative side effects. So I think they've done things with birth outcomes, to see if there's any impact there. So, just type in, marijuana legalization impact on whatever you're interested in. And there's probably a paper out there right now on it. But I thought it was kind of an interesting paper. It's also pretty simple. All we're really looking at here is a coefficient on this indicator for whether or not this thing was legalized, right? So you could really do this with any policy you're interested in as well. A lot of people are doing some things right now with COVID policies, right? And looking at 1 or 0. Did the state have this regulation or not? What was the impact? Okay. So I don't know. I thought it was an interesting look, an interesting kind of subject, and just getting more just hearing more discussion about linear regression. Hopefully we're picking up on the things that will help us out in the exam. Okay. Any other questions from me here? Should probably get out a little early today. So Friday, like I said, I'll put one more paper up. It's interesting. It's on major choice. And then we'll kind of start to work through a little bit of exam review. Also be looking for that video up on YouTube as well. I'll post an announcement once I get up there, but it'll be me working through one of the practice exams. And other than that, I'll see you guys on Friday.